In the animation, I think you clearly understood what is happening. So here electrons are revolving around, okay, around the nucleus. Here electron mass is some m. Okay, here we are sending the photon. Okay, this is having some energy ei. Okay, ei, frequency nu I or lambda I or wavelength. If you take any, you can take anything. Okay, it's not a problem. After hitting this one, okay, photon, this electron is going in this direction or any direction. In this any direction, we don't know actually. Okay, in this direction, electron is moving. This is electron. Okay, so here in this direction, photon is going. Photon. Okay, this is photon, or you can write photon. Okay, this is actually incident original path. This is the original path. Because of this scattering or because of this collision, electron going in this direction and photon going in this direction. Okay, now after scattering also, here I am drawing again this one. After collision, this is m, electron mass m. Okay, after that, this is I'm drawing again. This is photon and this is the electron. Okay, electron, we know mass, it is having mass m. Okay, so this is initially energy. What is the energy of incident photon? H nu I, right? H nu I. Okay, this uh, initially what he considered, Compton electron is at rest, but it is not rest. Always it revolve around the nucleus. But initially at the time of instant of collision, it is at rest. Okay, and X-ray also it is a photons. It's a stream of photons, and it is having energy of h nu. Energy of h nu, and these electrons also he consider it loosely bound to the nucleus. Loosely bound to the nucleus. Suppose if it is strongly bound to the nucleus, what we have to do? That time we have to give high energy photons. Then only these electrons go some other direction. It will release from the nucleus. Otherwise, this photon loss energy, but electron will not recoil. Okay, this is what you say recoil. This is recoil electron. Okay, recoiling. Okay, this is the scattering. The scattering means it is going some random direction. We don't know that is okay. This is the initial path of photon. Initial path of photon. So how much is scattered we can find using the angle from the initial path. Okay. Here also how much this electron recoiled we can see from the incident path. We can see how much angle it is deviated. Okay. Here this electron also having some energy EF. Okay. Here photon also having energy. Suppose that is EF. You can write photon. So yesterday what we have done, we have here what is the things, two formulas, main important formula, energy conservation. Okay, energy conservation law and momentum conservation law. Okay, energy conservation, and second thing is momentum conservation law, linear momentum. Here what type of momentum? Linear momentum is or radial momentum or angular momentum, or you can say here linear momentum also there. Here we are studying linear momentum. Okay, this elastic collision means these two, energy and momentum, always conserved. Inelastic means either energy conserved or momentum conserved, but or may not, both are not conserved. Okay, that is inelastic. Inelastic means may not conserve any of them or both. Okay, but elastic means both are conserved, energy and momentum. Okay, here we are considering energy conservation law in that case. So before collision, energy is equal to the after collision energy. Okay, before collision what we have? Photon and electron. After also we have to consider photon and electron, isn't it? Okay, here we have photon plus electron. Here also photon plus electron. These things we have. So we have to write energy for photon and electron. Okay, photon energy we know h nu I. Okay, h nu I, and electron energy we know rest mass energy E is equal to m naught c square, and here for after collision photon energy h nu f, and here energy also electron energy you can write. Here you can write energy of electron m square c to the power of 4 e square c square. Okay, this is the after collision. This one is the before collision. Okay, first we used the energy conservation law, right? Isn't it? Up to here, is it clear everyone? Up to now? Hello? Up to now everyone got
Yes.
the okay.
Yes, sir.
Nothing we are doing. Okay, just we are writing, we have electron and photon. We are writing before collision electron energy plus photon energy. After that, after collision, after scattering, we are writing electron energy and photon energy. Okay, that is initially photon energy is h nu I, and rest mass energy of electron is m naught c square. After that, final r scattered photon energy is h nu f plus, this is final recoiled electron energy is m square c square c to the power of p square c square under root. Okay, from there we have written p square value, right? Because we want lambda I minus nu I minus nu f, or lambda f minus lambda I, or you can write e I minus e f we want. This is the shift in the energy, this is the shift in the frequency, this is the shift in the wavelength. This thing we are going to estimate, shift in the energy or shift in the frequency, shift in the wavelength, that is we are going to calculate. So we don't want the momentum term here, so we are try to eliminate this momentum term using this energy conservation law and momentum conservation law. Okay, so here we have written yesterday up to just you square it both side, and you simplify, just simplify, and you write the expression for p square. Okay, that expression p square value is h square by c square. What is the expression? Nobody is followed, right? Running notes. Nu a plus nu a square 2 m naught 2 m naught h nu I minus nu f. So you are not following any running notes, right? Isn't it? So please write down just the equation part where you feel little bit difficult, little bit tricky. You just follow the running note. Just you write down. Then only it is very easy. Otherwise, just if you listen, you will not concentrate. That is the thing. Just you write down. Okay. This semester you may have completely online, but if you are not preparing now onwards, if you don't understand at a time, it is very difficult to study all subjects. So try to follow daily classes, daily only. Okay. So this expression, this expression we have derived. This is expression. Let's take equation one. Okay, equation one. Now we have to use momentum conservation law. Okay, momentum conservation law. So now I will write. Okay, here momentum. So I am writing here momentum conservation law. So here energy is scalar, right? Energy is scalar before, after, there is no particular direction. But after, in this momentum conservation, we have to consider direction also, because momentum is vector. Okay. See in this diagram, photon is going in this direction and electron is going in this direction. But we don't know what is the momentum here. That's why we are dividing into XY component. We are dividing X component, and here we are dividing Y component. Same thing here also, we are dividing X component, Y component of electron momentum. So from this X and Y component, we can apply conservation law and we can get the total momentum. Okay, right? So here this after scattering, photon is going in this direction, and after scattering, shall we take other page? Okay, shall we take other page? So I am taking new page. Here you can see clearly. So this is M. After scattering, photon is going in this direction and electron is going in this direction. This is electron. Okay. Here also we are considering two direction. This is X direction and this is Y direction. Here you can write P. So what is the angle here? Recoil angle pi. This is theta, right? This is theta and this is pi. Okay. This is H nu I. Okay. Whatever. Okay. This is P cos pi and this is P sin pi. So angle is pi. So we are taking, that's why X component is P cos pi and Y component is P sin pi. Here negative Y direction, right? This is negative Y direction. This is X direction. So you write here minus. Same thing you divided into momentum also. So what happened? So same thing you divide for here also, for photon also. This is P into P cos theta here cos theta, and in the y direction p sin theta. Okay, what is that? P sin theta. Okay, p sin theta. Or you can write here p is equal h nu by c also you can write. So first we will use the momentum conservation law along the x direction we will consider. Okay, along the x direction. Okay. First we will see along the x direction. What is the momentum here? What is the momentum here? And photon momentum is called E is called PC, right? E is called PC. Okay, E is called PC. From there you can write P is called E by C. P is called E by C. From there E is called H nu. We know H nu by C. H nu by C. So incident photon frequency momentum is H nu I by C. And what is the momentum of electron here? Before collision. Okay, before collision momentum, before collision momentum equal to after collision momentum. After collision momentum equal to before collision momentum. That is the along the x direction linear momentum conservation law. So what is the momentum of electron here? Anyone please? What is this? 73? Please switch off video. 73. Are you there?
Sorry, sir.
Okay, because what the condition you are there in at your home, we don't know. That's why please switch off your videos to convenient to all your friends. Okay. So what is the momentum of electron before collision? Okay, what are the assumptions? First of all, if you want to see what Compton consider for this scattering effect, what do you consider? Vishwanath, are you there? Vishwanath, what is rule number? What is his rule number? Don't know. No? So what is the anybody if you know or don't know, just at least tell me what are the assumptions he took. Can you hear me or no?
Yes, sir.
Okay, you don't know. If you don't know, please just tell me. We don't know. That's it. No need to worry. Okay, no need to suffer. Just if you know, answer. Otherwise, you simply respond. That is the primary thing. After that, whatever. So, what he consider electron is at rest initially. So, if it is rest means what? Velocity is zero, right? Velocity is zero. That means momentum also zero. Rest mass electron momentum is zero, right? So now what is the momentum of photon along the x direction? P cos theta, or you can write P is equal to h nu f by c, h nu f by c cos theta, and momentum of electron P cos pi. Here we are eliminating the momentum, you keep it like that, or you can substitute momentum value also. Is just before we have derived energy is equal to energy of electron is equal to what we have written here, is m naught m square c square c to the power of 4 plus p square c square. From there you can write the p is equal to p value, but it will be very again it will make complicated, so you keep it p as it is. Okay, from there you bring it these two terms one side. Okay, these two terms one side, because here nu I is there, h nu I minus h nu f by c, here also c, and here cos theta is there, just bring it down, bring it this side, and cos pi, right? So this is the expression we got, or you can square this expression. P square cos square pi is equal, okay, h by c nu I minus nu f cos theta. Cos theta, here you can square it out. Okay, you can square this, complete square it out. Okay, this is expression 2. Let's take 2. Expression 2. So we have used the momentum conservation law along the x direction. So momentum, and you have to find out again along the y direction. Okay, what is the momentum along the y direction here? Before and same formula you have to apply. Momentum conservation law along the y direction before collision and after collision. Okay, before collision, what is the momentum here? Photon momentum. Anyone please? Along the y direction we are applying. So what is the momentum here? Anyone? Before
P
collision I am
cos
asking.
theta.
Before collision. Before collision. That is after collision. Before
0.
collision. Yeah, very good.
0.
Okay. What's your name?
Tirupati sir, 5B1.
Oh, okay, okay. I could not see. Okay. So why it is 0, Tirupati?
At initial, it's 0 sir. Anything.
Photon is not photon is hitting, right? It is coming some it is having some velocity and hitting the electron. It is not rest, right? So why it is 0? Just before we have written h nu a by c, right? Someone is saying
Yes sir.
Initial momentum is equal to final momentum.
initial momentum equal to
Final momentum.
that is okay. See here why that answer is right 0, but the reason is not initial or not rest, because here if you see the diagram here, the photon is how it is going before collision, only x direction, right? There is no momentum of photon along the y direction, right? Only photon moving along the in this direction, x direction only, right? That's why photon initial before collision, photon moving in the x direction. There is no photon is not traveling along the y direction, right? That's why we are finding the momentum. We are applying the conservation law along the y direction. That's why there is no photon moving along the y direction before collision. That's why photon momentum is 0 before collision. And also initially what is considered Compton, electron is a rest, electron momentum also 0. So after that, after scattering, after, is this clear now why it is 0?
Yes, sir.
Before collision, photon only moving along the x direction only. It is not going to y direction or z direction, any direction. It is going along the x direction. So in case of x direction, we have photon, right? For here, see, in the x direction, we have applied conservation law, right? In this law, here photon momentum is there, h nu I by c, right? But in this along y direction, photon is not going to y direction, so momentum is 0. In the y direction, there is no photon before collision. So that's why it is 0. So after collision, that is P sine theta, right? You can write P instead of P, you can write H nu F by C, H nu F by C sine theta, H nu F by C sine theta. Along the y direction, what is the momentum of electron? What is the momentum along the y direction after collision?
Minus P cos theta.
P sine pi, sine pi.
P
Okay.
sin theta. Yes.
Sine pi. This is pi is the theta is the angle for scattering angle for photon. Pi is the recoil angle for electron. Okay, that is the difference. Okay, theta and pi. Okay, from this expression you can write in the second expression we have p square cos square pi, right? So here also you can square it out. Then we can add it this momentum along the x direction momentum, along the y direction momentum. We can add sum up and we will get the total momentum, right? Or resultant momentum. Or resultant momentum we will get, right? So here I am squaring directly p square sine square pi is equal to h nu f h square c square or nu f square sine square theta. Okay, this is the expression 3. Okay, you observe expression 2 and 3. You can write, right? You can sum up this 2 and 3, right? You can do it 2 plus 3. You can do it 2 plus 3. What we will get? Here sine square pi, here cos square pi. Sine square theta plus cos square theta is equal to 1, right? Isn't it?
Yes, sir.
So you can get the here p square, just p square, and you rewrite this expression h square c square, here nu I minus nu f cos theta square, and here h square nu f square c square, here sine square theta, right? Just I added these two expressions. Now what we'll do here, expression, let's take expression 4. So in expression 1 also, in equation 1, using energy conservation law, we have derived the p square value, right? Here also we got the, from the energy conservation law we got p square value. Okay, from momentum conservation law also we got the p square value. Okay, we'll will equal these two equations. We will equal 1 and 4. We will equal 1 and 4. Then we will simplify this expression. Is it clear now? What we have done here? So what we have done here, just momentum before collision. Just shall I show animation again? Just a minute. I will show it again. Okay. So here a very simple thing, but are you following or not? I don't know. Okay. So you can see, right, PPT.
Yes, sir.
So here, what we are doing? So initially, photon consider assumption electron is at rest, but photon is always along the x direction before collision, right? Before collision along the x direction, and after collision the photon is moving in some particular direction. That direction we don't know. That's why we are dividing x component, y component, and we are adding these two x and y component. Then we are getting the resultant photon direction. Okay, photon momentum direction. Okay, that is the thing we are doing in the momentum conservation law. Okay, momentum conservation law. So now we will add these two terms. Okay, now we will add we got the p square value from momentum conservation law and p square value from energy conservation law. We will equal these two terms. What is the first expression here? From the energy conservation law, we got E square h square c square nu I minus nu f square plus 2 m naught h nu I minus nu f. Now what is the expression for from 4? You can write this is h square c square is common, you can take out. Okay, you take out, and nu I minus nu f cos theta square plus nu f square sine square theta. Okay, this expression we got once we equal. Here h square by c square common. Uh, here you can take out common also, this one also. What we will get here? C square by h, right? C square by h we will get, and this one will cancel out, and you simplify this expression. Okay, I am rewriting this expression. So nu I square plus nu f square minus 2 nu I into nu f, right? Here 2 m naught h c square by h, 2 m naught c square by h, and nu I minus nu f, right? Nu I minus nu f, and here also I am completely rewriting this expression. Nu I square nu f square cos square theta and 2 nu I nu f cos theta. Nu I nu f cos theta plus nu f square sin square theta. Okay, right? From this expression, what we can simplify this one again? How we can simplify? Here nu square is there, here nu square is there. You can cancel out these two, right? You can cancel out this nu square and this nu square. And here nu f square cos square theta, here nu f square cos square theta. What is the value? Nu f square, right? Here nu f square. You will cancel out this nu f square, and this one you can cancel out. So what we have here? 2 m naught h c square, m naught c square. This h is not there, right? So m naught c square by h nu I minus nu f. Okay, I am bringing this term also right hand side. This term also right hand side. What we have here? 2 nu I plus nu I into nu f plus minus 2 nu f cos theta. Nu I nu f cos theta. Okay, from this expression, what we can take out for common here? 2 nu I nu f into 1 minus cos theta, right? 1 minus cos theta. Okay, from there we got here 2 m naught c square by h, here nu I minus nu f, right? Okay, now I will send this term here I will send this remaining term right hand side. Here I will keep only nu I minus nu f is equal to, here 2 cancel out, and what we'll have here h by m naught c square, h by m naught c square. Here 1 minus cos theta remains, right? Isn't it? And here nu I also there, nu I nu f also there, isn't it? Are you following?
Yes, sir.
Okay, so you but what we want, this is also expression in terms of frequency change, or you can convert into wavelength, that is nu is equal c by lambda, nu is equal c by lambda. Here I am rewriting this expression. Okay, here c by lambda I, or here c by lambda f, here h by m naught c square, here nu f what is c by lambda I and c by lambda f. Okay, and 1 minus cos theta, 1 minus cos theta. Okay, right? Now just you simplify this expression, what we will get? Lambda f minus lambda I, here c square is there and here c square is there, get cancel out, right? C here c square is there, this is square cancel out. Here c into c, right? This one c into c, here c square is there, that will be cancel out, and here finally you will get lambda
H by M
uh,
naught C.
c. Right, that's good. Just a simplification only, that is you can do it. So this is the,
1 minus cos theta.
yeah, this is the shift from the Compton. This is what we are calling Compton shift. That is h by m naught c into 1 minus cos theta. Here nothing is there, just simplification. You can just do it. Okay. This is the shift of shift what we observed, shift or loss in the energy of photon once make the collision with electron. Okay, delta lambda is called lambda f minus lambda I is equal to h by m naught c into 1 minus cos theta. So the shift is what it is depending on what parameter this lambda is depending on, shift of scattering photon shift. It is depending on what parameters?
Scattering of photons and recoiling of electrons.
It is only scattering angle mainly, that is good, that is correct only. Okay, it is mainly depending on theta. That means what? How much after making collision, photon is scattering, right? How much angle is scattered? Okay, and that scattering angle, using that scattering angle, we can estimate how much shift we got, how much energy that photon lost in this collision, in this scattering. Okay, that is H, we can calculate. Okay, now here, up to now, here is it clear, everyone? So just I am telling very in few steps. First, what we have done, we have here one this nucleus is there, electrons are revolving around the nucleus, but he considered electron is rest. So first initially he considered at rest, we are using some photon of energy h nu. Initially there he took x-ray radiations, but that also he considers stream of photons, they are having energy h nu, and that is energy also quantized, and these electrons consider is bound, loosely bound to the nucleus, and it is a elastic collision. Final one is elastic collision. He assumed these three things. After heating, this electron is recoiling in this direction or any direction, and photon also scattering some other direction. So in this scattering, how this electron is recoiled, that means some incident photon lost some energy to this electron. Okay, so to eject or to make collision, it is lost some energy to electron. After gaining energy from this photon, from this collision, electron moved one direction and photon moved in this direction. So once you hit the electrons using some photon losing energy. So in this collision, photon losing energy, that loss of energy or change in the frequency or change in the movement, change in the wavelength, we are finding using this expression. Okay, using that expression. First, how we estimated? Used the energy conservation law. We have written expression for p square, and we have used momentum conservation law. From there also we have written p square. After that we have equal these two expression. we have equal these two expression, and we retain the expression delta lambda. Okay, just first we used energy conservation law, and after that momentum conservation law, because this is momentum is vector, so we have derived x direction and y direction, and we sum up the momentum along the x direction, along the y direction, we summed up momentum, and we got the p square value. From there we simplified this expression, we got the delta lambda, that is the shift in the wavelength of a photon before and after collision or in this scattering phenomena. That is the what we have solved in this yesterday and today class. Okay, now is it clear or any doubt you have? It is a little bit lengthy calculation, but it is not tricky. It is lengthy, I agree, but it is not tricky problem. Okay, just easy only, just simplification. Just you have to apply energy conservation law. Before collision, after collision, energy is same. Okay, here energy of electron, energy of photon we have to consider, and momentum also you have to apply momentum conservation law before collision, after collision. So momentum is vector. Before collision, photon is going only one direction, that is x direction, but after collision photon is going some different direction and electron is going some different direction. So after collision, you have uh, for finding resultant momentum, you have to apply momentum conservation law along the x direction, along the y direction. You have to sum up these x and y direction, then you will get the resultant momentum. And from energy conservation law, we are getting momentum, and uh, conservation of moment also we are getting momentum value, and you equal these two terms, and you will get the delta shift, that is delta lambda you will get. And shift in the energy or shift in the frequency, shift in the wavelength you will get. Okay, that is h by m naught c into 1 minus cos theta. 1 minus cos theta. Theta is scattering